Hello everyone, here I am going to introduce our cluster and cloud computing group project. At the beginning, I want to introduce our system architecture. We want an Nginx service in our first instance to provide load balancing. For requests that need to access the dynamic data in our database, it will pass the request to the other three servers averagely. In this way, we can efficiently distribute the incoming network traffic to our backend servers in the cluster. Secondly, we use Docker Swarm to manage parts of our services. The containers which are in red boxes in this picture are managed by Docker Swarm. The container that with a global mode setting would run in each of our machines except the instance one. The container with a replicated deployed mode settings would run in one of the 4 nodes. Actually, we have 12 Twitter cooler in our cluster, each for different purpose. They will be distributed to different nodes in our cluster by Docker Swarm. We didn't include the CouchDB container into the Swarm because using Swarm to manage the CouchDB database could be counterproductive if the Swarm manager deployed 2 CouchDB together to the same node. The load balancing Nginx service is also not included in the Swarm because the port it uses contradicts to the other 3 reverse process Nginx servers. There are 3 swarm managers in our cluster. Any instance with an ID bigger than 3 would be set to be a worker. Why it is necessary to set the number of manager nodes to 3, it is because it can support manager nodes failure. The number of manager nodes should be an odd number and should be bigger than 1. In our cluster, we can only provide 4 nodes, so setting the number of managers to be 3 in our system is our best choice. In this way, our system can provide fault tolerance that one of our manager nodes can crash. We use CouchDB cluster with 4 nodes to improve our system's availability. We keep 3 replicates in our cluster, which means that any 2 nodes can be done in our system without crashing down our application. The fast RESTful API server, the Twitter coolers, and the Twitter analyzer of our system would only access the CouchDB database in their local host. In this way, error on a single node will not affect other nodes. Also, we use Nginx here to separate static from dynamic traffic. For accessing the static data on our website, like HTML and image file, the Nginx service would handle them itself. For accessing the dynamic data from the database, the reverse process Nginx server would pass the request to the USGit fast server through socket protocol. There are many advantages to separate static traffic. For one thing, it can help reduce the file I/O and storage consumption of our USGit fast server. Nginx is good at handling static traffic, which can provide a quick response to our front-end application. Furthermore, we can reuse the RESTful API in our front-end application to reduce workload. We use Ansible to deploy our system, which can provide a high scalability for our system. And now, I will show you guys how we deploy our system using just one command. Hello everyone, now I'm going to show how I use Ansible to create all the instance and volumes and the security groups things. Just use one command. So now you can see there's no volumes or nodes or instance and no security group here. And then now I'm going to create first I will first create 3 instances with 3 volumes, each 50 gigabyte, and then I would scale up to 4 instance and show how we scaled up how we use our easier way to scale up our system, our cluster. So first we would want one alt, yeah, and then enter our password. Oh, wait a minute, I entered wrong password. So first, it would install the PIP in the local host and update the PIP, install OpenStack SDK, create volumes on the Nectar. So now it's creating security group. So we set all our security group here. So if you want to add a security group, you can easily just set up the port here. So it will add the security group to the cluster just in one command. We use a complex loop in Ansible, which is a new feature, so that we can do loop in these rules, so we don't have to list one by one, which is here. So you can see that we use this loop, which includes another loop here, and then it will set up all the rules in the same group. So the things you can see, we defined rules here, this list here, and also the security group is also a list. So we do a loop in a loop. Yeah. So you can see we now create 3 volume, and the security group also create, and you can see it, we use for swarm we use this here 5000 77 4789, and for CouchDB we use this. Yeah. And the instance would automatically write to the inventory file after the Ansible finished the create. For now, you can see this node host here. So let's just wait for it to finish. Now the Ansible is gathering fact. So here the IP has been write into the inventory file. You can see it now. There's the IP. Why we want to do this? Because you may use Ansible one with tag to do some changing later. So by writing the IP to the inventory files, you don't have to run all of it before you can run your task. You can just run with tag and let the tag equals to the task with the same tag. After the instance have been created, the first thing is to add policy to the environment, because in the lecture you can't connect to the internet if you don't set the policy properly. And after it set the policy, it will reboot. After reboot, it would install some dependency which is specified in server policy, and which is specified in server environment. Yep. So here for the apt get, we can write all of it here. So after that, we would create a directory which we would mount it to the volumes we create before. So now first create a directory and then mount it to the volumes we created. We mount it to data, which we will store the data we harvest from the Twitter. So because we will pull the GitHub report we will put a Git report from our GitHub, so we have to set our Git config, and then we would clone the report from the GitHub and create a config directory for the things we would use later. So we use Docker in our project. So first we will install Docker, and then create this file, because if you want to connect to the internet in Nectar, you still have to set some environment variables in Docker. So we have to say it. And then after you set the config files, you have to restart the Docker. So we do it here. And then collect that, set master IP address. We use IPs in mastered in we have a master in our cluster, but actually it is not really a master. We just use it to set up our CouchDB, and we would let it be the first manager in our cluster. And yeah, let's continue. Now we are installing CouchDB, so you can see the CouchDB has been installed, or the cluster has been installed correctly. So you can see cluster finish, and all nodes and cluster node is what we want. Yep. So because we may have to use some history to analyze data we generate by the data we harvest before, we would set the structure, the data structure, those map reduce things in the database first, and we use those history analyzed data. Yeah, the analyzed data is very small, which is generated by analyze the raw data of Twitter. So we also use Docker Swarm in our project, and there will be 3 manager in our project, and after if we got more than 3 nodes in our cloud, in our cluster, we would let the 4th one to be a worker. So we would got 3 manager, and others is all worker. So you can see it. Because the master node is already a manager. We only have to add another 2 nodes to the manager node. So we got 3 manager node. And then because we have 3 nodes, so there would be no worker. So now you can see we finish all of it. Let's get into it to see what happens. Okay. So now what I want to show is Docker node ls. So now you can see we have a manager node, and the other is also manager node, but now there would be only 1 here. Yep, because they are just ready to become a manager if these ones died. Yep. And then let's have a look at our website. Yeah, this is our website, and for the part of showing the website, we have another part, so I will first skip this part now. Yep. And then what I want to show is to scale up our cluster. So what I have to do here is to set the variables of nectar, and then we would add one more volume to it, and then we would add one more instance to it. So what I want to show is that now there's only three instances in our cluster. Yep, you can see there is only 3 instances in our cluster. Now I'm going to scale up our cluster. So what I have to do is, oh, wait a minute. Yeah, and then we would run all again. So we'll build a new instance. The process is much the same. So now you can see on the fourth node, the fourth instance have been created correctly. Let's see its inventory. Yeah, it has been added to the inventory. Oh, here you can see the cluster, the CouchDB cluster has been set up properly, and all of them is in the cluster node. And then now one of it becomes a worker. Okay, now all of the instance has been created properly, and we can go to check whether we can access this instance for. So wait a minute. Yep. Yeah, you can see our website show properly in this IP address.
So let's continue the demonstration of our project by group 17. So in previous section, we have showed how to deploy our whole system through Ansible. So in this section, we are going to check our CouchDB setup and check our tweet harvesters, and also we are going to explain a little bit about how we do the analytics. So next, we are going to check the CouchDB setup. Let's go to the Malware Research Cloud and our group page. You can see that the 4 instances are successfully deployed here, and so each instance there will be a CouchDB Docker installed, and they are connected together to form a cluster. So next step, we're going to connect to the first instance and check our CouchDB setups there. And so here, we have been connected to instance 1, and then we're going to check the membership of our CouchDB. So from here, you can see that we have a 4-node cluster setup, 4 nodes here, and all node is connected to the cluster. So actually, you can access our CouchDB from any of these 4 IP addresses. So next, let's go check our tweet harvesters. So since our analytics are based on 5 major cities in Australia, we will have 1 tweet harvester for each of the cities, and also we will have 1 harvester for all Australia regions, including all cities included. And we are going to run the harvester for both streaming and historical tweets. So during the initial deployment, there will be 12 tweet harvesters running on our system, but the historical tweet harvesters will be stopped after they have run like 7 days of data. Okay, and also all the tweet harvesters are managed by Swarm in Docker. So next, let's go to our instance Swarm and check the Docker services here. So here you can see that we have successfully deployed all our services here, including the backend and the RESTful API server. And also we have deployed all the tweet harvesters here. You can see that we deployed them in a replicated mode, and they only have one instance. So in case any of the node instance failed, the Swarm will automatically reboot the same harvester in another instance. Okay, so to guarantee that the tweet harvesters are running successfully, we are going to check the logs of one of them. We are going to check the log for the streaming tweet harvester for all Australia region. And from the log, you can see that we can save data into the CouchDB. And also, if the Twitter has already been saved, it's a duplicate record. We can detect them and ignore it. And next, we are going to introduce how we do analysis by using CouchDB. So our general architecture looks like this. We are going to collect tweets from Twitter API, and by doing simple cleansing and transformation to align the tweet formats, we're going to save them to CouchDB. And then we are going to use MapReduce functions to extract the data and passing them to the analysis module. And we are going to do a lot of process here to analyze the data. And the output analysis results will be saved back to CouchDB again, and then the results will be passed to the front-end web service for visualization purpose. And the special thing about our system is we are going to do an incremental update here by doing analysis, because during the development phase, we have collected like 8 million tweets data. And in the first, we were trying to use MapReduce to calculate everything at a single point of time, but as the data volume grows, the performance drops quickly. So we decided to use an incremental update on the analysis results. So for each time, we are going to only to get newly saved tweets from CouchDB here and pass them to the analysis module. So every time we will analyze only the latest tweets collected. So we can do this by using a timestamp. So when we collect the Twitter, we will insert a timestamp into the tweet data and save them to the database. And then we are going to use MapReduce to extract the data by the latest timestamp and pass them to analysis module. And every time the analysis module gets an update on the analysis results, it will save back to the CouchDB. And in such a way, we can increment, update our analysis results. So this architecture also simplifies our deployment. So we don't need to migrate millions of tweets here. We only just need to migrate the analysis results from the development phase to the deployment, and then just let the system go get more tweets and do more analysis. And then let's go to our CouchDB web portal to check our MapReduce functions. So let's connect it to the CouchDB. We can see we have 3 different databases. The analysis results save our analytic results. The data that will be shown on the front end, and Orange saves the data we collected from Orange, and TweetMix saves all the Twitter data we collected here. Let's refresh the page. We can see the number of documents increase, which also proves that our tweet harvester works well. And let's go to the tweet harvester. Let's check our views. We will have a view by timestamp and city. And for this view, we are possible to get all our data by timestamp and by different cities to our analysis module. Let's just simply run the query to see. By different timestamps, we are going to extract different cities since our analytics is based only on the 5 major cities. So that's it.
Hello everyone who's watching this video. This is the Cluster and Cloud Computing Project user interface demo, and we are group 17. The aim of this project is to find interesting stories in Australian cities by using the tweets harvested across Australia and data from AURIN, the Australian Urban Research Infrastructure Network. We have 6 analytic scenarios across 5 main cities in Australia. 3 scenarios are at city level, and the other 3 of them are at suburb level. Let's move to the city level scenarios first. The first one is the relationship between the number of tweets that mention coronavirus and the number of followers those tweets posters have. That is, are the users with more followers more likely to mention coronavirus in their tweets? There are reasons for us coming up with this scenario. Users with more followers usually have a greater sense of social responsibility than normal people, so they may care more about the virus, which is affecting everyone. Also, users would draw more attention from the public if they talk more about hot topics. Well, there's always a reason that someone is the one with more followers. As a result, we can see that our assumption is correct, and a larger proportion of the tweets mentioned coronavirus are from Twitter users who have more than 500 followers, but only a few of them were tweeted by users who have less than 100 followers. The situation in each city are basically the same. The next scenario is the young people's preferences when tweeting. We would like to see whether a city has more night tweets and located tweets if the city has larger proportion of young people. By young people, I mean people aged between 15 to 35. And night tweets are the ones that were tweeted between 11 p.m. to 4 a.m. We made a guess that young people are more likely to stay up late, and young people would love to share where they are when they tweet to show some nice food or some fancy activities or stuff like that. So they have their location label turned on, but the result shows that there's no such relationship. It might be explained by the fact that we are in a very special period. So people don't want to share their locations because they have nowhere to go, and Twitter might not be the nice social media choice for young people because we also have Instagram and Facebook, etc. From plot, we can see that Perth is the city with the biggest proportion of night tweets, and Adelaide is the one with biggest proportion of located tweets. The third city scenario is tweeting frequency versus the proportion of people who speak English as their mother tongue. The result shows that cities with lower proportion of native speakers have a relatively high tweeting density. For example, Melbourne has um, only 62% of people whose mother tongue is English, but there are uh, about like 33 tweets per user in Melbourne. Um, okay, those are our city level scenarios. Let's go to the map and see the suburb level scenarios. As you can see, we have 5 cities and 3 suburb level scenarios. Let's just use Melbourne for illustration. First, income level and tweet sentiment. The reason why we have this scenario is that we want to see whether people have a greater income will post more, positive tweets. The color showing on the map represents the income level for each suburb. The darker the color is, the higher the average income the suburb has. Now, if I click on the suburb, we can see 2 pie charts. The left one says about like 54% of the tweets from Docklands are neutral, and about 41% of them are positive, and about 5.2% are negative. We did this by analyzing tweet sentiment. Um, the right pie chart says that about 56% of people from Docklands have middle income, and about 28% of them are, have low income, and 15.5% for high income. Um, we also have similar pie charts for other suburbs. If we scroll down, we can see the horizontal comparison across suburbs in Melbourne. Each suburb has 2 bars. One is the proportion of high income people, and the other one is the ratio of number of positive tweets to number of negative tweets. We can clearly see that there is a relationship. Suburbs with bigger proportion of high income people do have more positive tweets. Okay. Secondly, vulgar tweets and education. The darker the color is, the bigger vulgar tweets proportion is. The left pie chart represent the relative contribution that people do and don't complete year 12 contribute to the overall total. The red one shows that the proportion of young people who are or are not in study or work. And for the bar chart, we use a scaled proportion of vulgar twist, to see the results clearer. That's 10 times the proportion. And the proportion of people with low education achievements. I don't know what's going on with this, but no offense. We can see that there is a relationship saying that suburbs with higher proportion of people with low education achievements have bigger proportion of vulgar tweets. The last one is tweeting language and migration. the darker the color is, the higher the non-English tweet proportion is. The left pie chart has two slices, which are proportions of people do and don't speak English at home. As for the right one, it has proportions of where people were born. Okay, and let's go to the bar chart. Oh, there is a relationship, as we can see, between non-English tweet proportion and proportion of people don't speak English at home. Oh, and we also have similar analysis for other cities. Let's see. That's Sydney and Brisbane. And Perth. Okay. I guess that is for today. Thank you so much for watching.